assertion and reason type. In this type, you will be given two statements, statement 1 and statement 2. If statement 1 is true and statement 2 is true, and because of statement 2, statement 1 is right, you mark it as capital A. Statement 1 is true, statement 2 is true, but 2 does not imply statement 1, you mark it by capital letter B. Statement 1 is true, statement 2 is false, you mark it as C. Statement 1 is false and statement 2 is true, you mark it by capital D. Problem 18, the first statement is there, the second statement is there, and you can very easily check that using the rule arithmetic mean is greater than equal to geometric mean. Statement 2 is right. Let us check the statement 1. Because of statement 2, I get cube root of s minus a into s minus b into s minus c less than or equal to 3s minus a plus b plus c, 3s minus 2s by 3, that is less than or equal to s by 3. Remove the cube root. So, s minus a into s minus b into s minus c less than or equal to s cubed by 27. Take the square root. So, root of s minus a into s minus b into s minus c less than or equal to s by 3 root 3. Multiply by root s both sides. Square root of s into s minus a into s minus b into s minus c will be s cube here taken. I should have here s power 3 by 2 here. Square root of s cubed is s power 3 by 2 there. So, I get root s into s power 3 by 2, that is s squared by 3 root 3. You know the area of the triangle is given by the formula root of s into s minus a into s minus b into s minus c. Therefore, delta less than or equal to s squared by 3 into root 3. Whereas in the statement 1, you are given that the maximum area is 2s squared by 3 root 3. So, statement 1 is false, statement 2 is correct. Therefore, it comes under the category capital D. Question 19, two statements are given. We have to verify which one of them is true. Statement 2 is obvious. Tan A plus B, tan A plus tan B by 1 minus tan A tan B. Tan A tan B are the roots of this equation. Therefore, tan A plus tan B is equal to A. Tan A tan B is equal to B. Therefore, substituting this formula, tan of A plus B, tan A plus tan B, A by 1 minus B. That implies cot of A plus B is 1 minus B by A. So, cosecant squared of A plus B, which is 1 plus cot squared A plus B, 1 minus B by A whole square. That is A square plus 1 minus B whole square by A square. This implies sin squared A plus B is equal to A squared by A squared plus 1 minus B whole square, which is the statement 1. So, statement 1 is right, statement 2 is right, statement 2 implies statement 1, so it comes under the category capital A. Question 20. Statement 1 says that if two consecutive integers are the roots of the equation x squared plus bx plus c equal to 0, then b squared minus 4c equal to 1. Statement 2 says b squared minus 4c is the difference between the roots. So, let us take n plus 1 be the two roots. Therefore, n plus 1, that is 2n plus 1 equal to minus b. Product of the roots, n into n plus 1 is equal to c. Let me take the expression b squared minus 4c, that is 2n plus 1 whole square minus 4 into n plus 1, 4n squared, 4n plus 1 minus 4n squared minus 4n, which is equal to 1. So, statement number 1 is correct. Now, the difference between the roots alpha minus beta whole square, that will be alpha plus beta whole square minus 4 alpha beta, that will give you 1. So, square of the difference between the roots is 1. Not the difference between the roots is b squared minus 4c. Therefore, b squared minus 4c is the difference between the roots. That statement is wrong. Statement 1 is correct. Statement 2 is false. Therefore, it comes under the category capital